Hello, welcome back. In this video, we are going to discuss exercise 7.1 from the chapter Triangles. This is part 2 of the video, and in the first part, we discussed question number 1 to 4 from exercise 7.1, and in this part, we are going to discuss question number 5 to 8 from exercise 7.1. And before starting, if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications. So let us start now. Fifth question is, line L is the bisector of an angle A and B is any point on L. So L is the bisector of angle A and B is any point on this L. BP and BQ are perpendiculars from B to the arms of angle A. What are the arms of angle A? It is this arm and this arm, right? So BP and BQ are the perpendiculars to these arms. Now, the first part is we have to prove that triangle APB is congruent to triangle AQB. So, how will we prove that? First, we know that these two angles are same. That is, angle BAQ and angle BAP are the same. Why? Because this L is the bisector. Given that L is the bisector of this angle A, which means bisector divides one angle into two equal parts. So these two angles will be the same. So we can say that angle BAP is equal to angle BAQ. And we can write in bracket since L is the bisector of angle A. Okay. Now, next is since this is perpendicular. These are perpendicular, BP and BQ are perpendiculars to these arms. What will be this angle? That is angle APB is equal to angle AQB is equal to 90 degree. And we can write in bracket since BP and BQ are perpendiculars to the arms. Okay, so we got these two angles as equal, and we have to get one more side which is equal. Which side is equal? AB is common side of both the triangles, which means AB is equal to AB, and we can write in bracket since this is the common side. So we can write common side. So we have got two angles and one side as equal. And which criteria will it satisfy? Which criteria or rule will it satisfy? It will satisfy AAS rule, right? So since this satisfies AAS rule, we can say that triangle APB is congruent to triangle AQB. And next part is we have to show that BP equal to BQ or B is equidistant from the arms of angle A. That is, we have to prove that BP is equal to BQ or B is equidistant from both the arms of A. That is, this B is equidistant from both P and Q. We have to prove that. So, how will you prove that? Just we know that triangle APB is congruent to triangle AQB and corresponding sides of congruent triangles are equal by CPCT. That is corresponding parts of congruent triangle. So from that we can say that BQ is equal to BP or B is equidistant from both the arms of angle A. Okay, understood? Next question is in the given figure AC is equal to AE. AC is equal to AE and AB is equal to AD. Okay, AB is equal to AD and angle BAD is equal to angle EAC. Show that BC, this BC, we have to show that this BC is equal to DE. Okay, so for that we can prove that these two triangles, that is triangle ABC is congruent to triangle ADE. Then we can say that BC and DE are the corresponding sides of the congruent triangle, and from that we can say that BC equal to DE. So first we have to prove that triangle ABC is congruent to triangle ADE. How will we prove that? we have to take this full triangle and this triangle. We have to prove that these two triangles are congruent. And we know that angle BAD is equal to angle EAC. So if you add this angle to both these angles, will that be equal? Yes, because these two angles are equal, and when you add this to both the angles, it will be equal, right? So angle BAD plus angle DAC is equal to angle EAC plus angle DAC. And from that we get that angle BAC is equal to angle EAD. So we got one angle of both the triangles to be equal. Okay. Now we are given that AB is equal to AD. Okay, so we can write given here. Okay. And now AC is equal to AE. That is also given. So we got two sides which are equal and one angle in between the sides which are equal. Hence, we can say that these two triangles are congruent. That is triangle BAC and triangle EAD are congruent. Triangle BAC is congruent to triangle DAE. Okay, because these two sides are equal, so we have to take the corresponding sides, which means BAC and DAE. Okay, from this we can say that we have to prove that BC is equal to DE, and BC and DE are the corresponding sides of these congruent triangles. And from that we can say that BC is equal to DE by CPCT rule, that is corresponding parts of congruent triangles. Okay, so we got BC is equal to DE. Understood? Next question is AB is a line segment and P is its midpoint. D and E are points on the side of AB such that angle BAD is equal to angle ABE and angle EPA, that is this angle EPA, this angle is equal to angle DPB, that is this angle. Okay. Now you have to show that this triangle DAP is congruent to triangle EBP and AD. This AD is equal to this BE. Okay. So what we will do is first we will prove that triangle DAP is congruent to triangle EBP. We know that in both the triangles given that angle BAD is equal to angle ABE. So we can write that angle BAD is equal to angle ABE, that is given. Okay, so we have got one angle which is equal. Now we have to prove that this full triangle DAP and this full triangle EBP. So here this angle will also be included in this triangle, and in this triangle also this angle, that is angle EPD, will be included. We have angle EPA is equal to angle DPB, right? So when you add this angle EPD to both, it will be equal. EPA plus angle EPD is equal to angle DPB plus angle EPD. Okay. This is equal, right? Now, what is angle EPA plus angle EPD? It is angle DPA, right? So, this side is angle DPA is equal to angle DPB plus angle EPD is angle EPB, right? So, this is equal to angle EPB. So we got two angles which are equal. We got this angle to be equal and these two angles to be equal. And we want one more side which has to be equal. And for that we know that this P is the midpoint. P is the midpoint of AB. So this AP will be equal to PB, right? Since we can write here P is the midpoint. So we got two angles which are equal and one side which is equal. So this satisfies ASA congruence rule. From this we can say that these two triangles, triangle DAP is congruent to triangle EPB. Okay, so we got triangle DAP is congruent to triangle EBP, and next we have to prove that AD equal to BE. Will AD be equal to BE? Since triangle DAP is congruent to triangle EBP, this AD and BE are the corresponding sides of these two triangles which are congruent, and from the CPCT rule, that is corresponding parts of congruent triangles, we can say that AD is equal to BE. Okay, understood? Next question is, in a right triangle ABC, right angled at C, M is the midpoint of hypotenuse AB. M is the midpoint of this hypotenuse AB. C is joined to M. C is joined to M and produced to a point D such that DM is equal to CM. DM is equal to CM, and given that M is the midpoint of the hypotenuse AB, so these two sides will be equal, and point D is joined to point B. D is joined to B. Okay, show that triangle AMC, this triangle AMC is congruent to triangle BMD. And second part is we have to prove that angle DBC is a right angle. Then we have to prove that triangle DBC is congruent to triangle ACB and CM equal to half of AB. First, we have to prove that triangle AMC is congruent to triangle BMD. This triangle is congruent to BMD. Here given that AM is equal to BM because M is the midpoint of AB. So AM is equal to BM. Then we have DM equal to CM. Given that DM equal to CM. Now what about these angles? They are vertically opposite angles, right? So these angles are also equal. Angle DMB is equal to angle CM. So we got two sides which are equal and one included angle which is equal. So this satisfies SAS congruence rule. From this we can say that triangle AMC is congruent to triangle BMD. Okay. Next is we have to show that angle DBC is a right angle. Angle DBC is a right angle. For that, if we prove that this triangle ABC is congruent to triangle DCB, then we can say that angle DBC is right angle because angle ACB, given that angle ACB is right angle. So if we prove that these two triangles are congruent, we can say that angle DBC is also right angle. So to prove that these two triangles are congruent, we have got that triangle AMC is congruent to triangle BMD, right? So when you add this triangle to both, that is plus triangle BMC in both, it is same, right? So this is also congruent. When you add triangle BMC to both, this is also congruent. And what is triangle AMC plus triangle BMC? It is triangle ACB, right? So triangle ACB is congruent to, and triangle BMD plus triangle BMC. BMD plus BMC is triangle DBC. So we got these two triangles are congruent, and angle C, that is angle ACB is equal to 90 degrees. So angle DBC also will be equal to 90 degrees. So we got angle DBC is a right angle. So we have proved that angle DBC is a right angle. Next part is we have to prove that triangle DBC is congruent to triangle ACB. We have already done that. We proved that angle DBC is a right angle by proving that triangle DBC is congruent to triangle ACB. Next part is we have to prove that this CM is equal to half AB. Okay, we have got that triangle DBC is congruent to triangle ACB, right? So this DC are the corresponding vertices of the triangle. So DC is equal to AB. That is, this DC will be equal to AB, right? So we got DC is equal to AB, and we have to get this in terms of CM. So what is DC in terms of cm? It is 2 cm. So 2 cm is equal to AB. So what is cm? Cm is equal to half of AB, right? So cm is equal to half of AB. Okay, we have completed 2 volumes on the basic concepts of this chapter triangles, and we have 2 parts for example 7.1. So we have finished till exercise 7.1. So I'll be uploading volume 3 of the basic concepts in the next video. Stay tuned. And if you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications. Thank you and bye.